Okay, and welcome to the long answer questions section for test 1 of Pre-Calculus 40S. Let's get started. Okay, the first long answer question is asking you to describe the transformations. Okay, so there are 4 different transformations, and you have to give them in the correct order in which they take place. Okay, so the 4 transformations are as follows. We'll zoom in here. We have to reflect vertically over the x-axis. That is given here by the negative sign out front. We have to vertically stretch by a scale factor of 4. That's this 4 out front there as well. From this point, in terms of order, those first 2 must come first, and the next 2 must come last. And you can place either pair in whatever order you want. Okay, for the translations, we have a translation up 1 unit. That's the +1 on the end. We have a translation 3 units to the right, so a horizontal translation 3 units to the right. That's that -3. Okay, quite a lot of things. So each one of these was a half point, half point, half point, half point for all the net identifications, and then 1 point for the correct order. Okay, we'll zoom back out. Question 2. So we have a transformation here, and this is a very open-ended question. I want anything that results in a horizontal stretch, anything that results in a vertical stretch, a reflection over the y-axis, and any kind of translation to the left. Okay, and so let's see. Here's my vertical stretch. This 1/2 gives me my horizontal stretch. This negative sign gives me the reflection over the x-axis. And finally, this +8 gives me a horizontal translation to the left. Okay, now you could have done any other number in those 3 number cases, although you do need the negative sign where it is. Okay. Number 3, there's 3 possible answers that I can think of, although there'd be others still. The first method here is just to show me a single example where this fails to inverse. So for example, if you input 0 into F, you get 5. But if you input 5 into G, you get 11/5. So you don't get back the original thing that you inputted. So we can conclude they're not inverses, and you might write it a little nicer than I have. Method 2, you could graph both functions, and you would see that they're not inverses, and you'd be able to show that. I'll let you do that if you want. And finally, method 3 is kind of a neat little bit of algebra. Is this rule must apply that if 2 functions are inverse of each other, then evaluating one of the functions in the other function should result in a value of x. In other words, if I input x into G, then input that result into F, if it's an inverse, it'll give me back the original x. But in this case, you could show algebraically quite easily that f of g of x does not give you x, and therefore it's not a pair of inverse functions. Okay, next is the graphing. So we have 4 graphs to do, and I just looked at the original graph and I identified what I'm calling the key points on y equals f of x. You could identify different points, but these ones are really key. The 2, 3 is the point where it stops. -1, 3 is this corner over here, and -2, 0 is this intercept. Okay, and I just decided to use those 3 points when I was sketching this myself. Okay, now here's the resulting graphs, and each one of them has a mapping notation next to it. Now you might want to pause the video here if you want to take a look at the detail. Let me know if there's any questions. Okay, otherwise I'm going to move on to the next question. Okay, next page, final page. Here are 2 possible answers, and I'm going to have to give you some justification. So how did I get to these things? Well, I'm just going to look at the first answer, and the second answer just flows from that. G of x is equal to 3 times f of x plus 3 minus 4. So 3 transformations have taken place on f of x. Okay, what has taken place? First off, you'll recall from the test, I did note that these graphs are slightly off in the printing, and so we did have to make an adjustment. Here's my thought. If I go out 1, I go up 1, starting from the vertex on f of x. But on this new function, I go out 1, wait a minute, I go up 3. So you notice that I've had a vertical stretch by a factor of 3. That gives me this 3 up front. Okay, now that I have that, I'll note that the vertex is unaffected by that vertical stretch. It's an invariant point. So it'll still be there after the vertical stretch takes place. I then ask myself, well, how far does that vertex travel to end up at this final location? Well, it had to go down 4, and it had to go to the left 3. The down 4 gives me this minus 4 on the end, and the left 3 gives me this plus 3 over here. And I'm done. Okay, as I said, the alternative is just the same thing. It's still the same transformations. It's simply just altering the function as given. Okay, next question. Given the graph of, this is a good one. Given this transformed graph in black, sketch the original graph. Okay, so the transformed graph is the one that's given. It's over here. And so I just kind of made this little table to think about things. Don't know if this is the right approach, but it seemed good to me. I looked at what the mapping would be, and then I said, well, on the original graph, there were points that went through this mapping process. So for example, one of the points that was over on the original graph of f of x got transformed into the point -2, -3 through this rule here. Well, what was the original point? Well, the original value of x must have been -4, since if you add 2 to -4, you get -2. And the original value for y must have been 0, since if you subtract 3 from 0, you get -3. And so that gave me this point over here on the graph of -4, 0. From here, I'll let you finish that off, but that should be your final graph. Last question. Okay, to determine the inverse equation of this function. You know what? This is an old version. We had edited this, so if you look at your question that was printed, you got a slightly different version because that's an error. We actually can't give an inverse function, but we could give an equation of the inverse and that's what's on your page. So anyway, to inverse, the x becomes y and the y becomes x, and so that's what I do to start. I then have to isolate the y, so I subtract 1 from both sides. I square root, and notice that I have to get a plus or minus out front there for reasons we've discussed. And then I add the 3 to both sides, and I end up with this final result. By the way, if I had actually asked for an inverse function, that's not possible here, since this plus minus means that we don't have a function. However, if we restricted the domain of f of x, that would give us a final function. But this question doesn't ask us to restrict the domain so as to create an inverse function. It simply asks for the inverse relation, and so that's the answer I've circled here. Okay, that's the end of the test. Thanks very much, everyone.